fact, you don't need all these steps to figure it out, that m prime is 1/3 m. You can figure it out quickly by saying that if F0 produces an acceleration of 3 meters per second squared on a mass m, the same force producing an acceleration of 9 meters per second squared on a mass m prime. This m prime, since the acceleration is 3 times the original value, the mass has to be 1/3 of the original mass. So m prime equal to 1/3 m. Okay, what is it that we need to find now? See, the two objects are now tied together. What is the total mass? M plus m prime. Well, this m prime can now be replaced by 1/3 m. So that will be m plus 1/3 m. What is m plus 1/3 m? That is 4/3 m. So the total mass now is 4/3 m. And we are applying the same force F0 on this 4/3 m. We want to find the acceleration. The net force equal to ma. The net force is F0 and the total mass is 4/3 m, and acceleration we need to calculate. Tell me, how will we do this problem? What is the next step? Well, glaringly obvious. Replace your F0 by 3m. Is that right? Okay, so F0 is replaced by 3m. 3m equal to 4/3 ma. Look at that. On the left and on the right, m will cancel. And we can then solve for a. A equal to 2.25 meter per second squared. A very good question to understand the concept we discussed. Alright, I want you to look through this again and try to argue this out on your own. Okay, let's do another problem. A force F equal to 6 Newton I minus 3 Newton J acts on an object of mass 1.5 kilogram. Find the acceleration of the object. What is its magnitude and direction? Well, we have done this kind of problem before. Acceleration is F net over the mass. F equal to ma, therefore A equal to F over m. This is the force and this is the mass. Therefore, acceleration is, you notice that the force has an x component and a y component. The x component of the force will produce an x acceleration. The y component of the force will produce a y acceleration. So, the acceleration in the x direction will be the x force divided by the mass. That is 6 Newton divided by 1.5 kilogram I. This will be the acceleration in the x direction. Minus, why minus? Because the y force is negative. 3 Newton divided by 1.5 kilogram J, and this is the y component of the acceleration. And that will be A equal to 4 meter per second squared I minus 2 meter per second squared J. This is the component form of the acceleration. How do you write it in the magnitude angle form? Well, the magnitude of the acceleration will be square root of x squared plus y squared. So A equal to square root of 4 squared plus 2 squared. That is 4.47 meter per second squared. And what is the direction of that acceleration? Notice that y is negative, x is positive. Tell me, what is the quadrant in which this acceleration vector is going to be. Y is negative, X is positive, it is the fourth quadrant. So the direction is theta equal to tan inverse of Y over X. Tan inverse of, I'm missing something here, negative 2 divided by 4. Tan inverse of negative 2 divided by 4, and that must be negative 26 degrees. Alright, now correct those small mistakes there. Theta equal to tan inverse negative 2 divided by 4, and that is negative 26.6 degrees. I hope you have now a fair understanding of how to do problems using the equations of motion we developed in Unit 1 and the laws of motion. Let's do another one. A 4 kilogram object is subjected to two forces, F1 equal to 2 Newton I minus 3 Newton J, and F2 equal to 4 Newton I minus 11 Newton J. The object is at rest at the origin at t equal to 0. What is the object's acceleration? What is its velocity at time t equal to 3 seconds? Where is the object at t equal to 3 seconds? You notice that these are extensions from the problems we did in Unit 1. Okay, how do we start here? We know there are two forces on a particle of mass 4 kilogram. We need to find the net force and use the net force to find the acceleration. Alright, let's get going. F net equal to F1 plus F2. So F1 plus F2, add the X components and add the Y component. That will be F1 plus F2. The X components will be 2 Newton I plus 4 Newton I. That will be 6 Newton I minus 3 Newton J minus 11 Newton J is minus 14 Newton J. So that is the net force. Add the X components, add the Y components. Therefore, what is the acceleration? Acceleration is the net force divided by the mass. We can do that now quickly. You know how to do that. That is X component of the force divided by the mass gives you the X component of the acceleration, and the Y component of the force divided by the mass gives you the Y component of the acceleration. That will be 1.5 meter per second squared in the X direction minus 3.5 meter per second squared in the Y direction. That means if you now use this acceleration to calculate the velocity at t equal to 3 seconds, you need to calculate the X component of the velocity and the Y component of the velocity. The X component of the velocity is produced by the X component of the acceleration, and the Y component of the velocity is produced by the Y component of the acceleration. Alright, let's do that. V0 equal to 0, and we're going to use Vf equal to V0 plus AT. Now, V of 3 is V0 is 0 plus A times 3. Now, V of 3 has an X component and a Y component. What does V of 3 stands for? Velocity at the end of 3 seconds is acceleration multiplied by 3. Now, when you use acceleration, the X value, that will be the X velocity. If you use the acceleration, the Y value, that will be the Y velocity. And we can write it together. In other words, if this is the acceleration in the component form, multiply that by 3, you will get the velocity in the component form. Let's do that. So velocity at the end of 3 seconds is acceleration multiplied by 3. In other words, multiply the x component of the acceleration by 3 minus multiply the y component of the acceleration by 3. That will be 4.5 meter per second I minus 10.5 meter per second j, and this is the velocity vector at that time. And if you want to find this in the magnitude angle form, you can do so. You know how to do that. Alright. In the C part, where is the object at t equal to 3 seconds? What is its position? Because the object has an x velocity and a y velocity, it will travel an x distance and a y distance. So where is the object? What is the position? There is an x position and a y position. And look at this equation. X of t equal to x0 plus v0t plus 1/2 a t squared, where x0 is 0. We will assume that the object is at the origin. So x0 is 0. What is v0, the initial velocity? Is 0. Yes. So these two terms will simply cancel. And therefore x of 3, the position at t equal to 3 will be, x of 3 will be 1/2 a times 3 squared. And that is, remember, this x really does not represent x. You've got to really call it some r, because this position has an x component and a y component. This is the x position of the object at t equal to 3. 1/2 a t squared, where this a is the x component of the acceleration, minus 1/2 a t squared, that is the y component. So this is the x component of the acceleration, and this is the this is the x component of the position, because this is the x component of the acceleration. This is the y component of the position, because this is the y acceleration. That will be 6.75 meter I minus 15.75 meter j. In other words, the particle at that time is 6.75 meter along the x direction in the positive way, and negative 15.75. So the particle has moved. If I use here, the particle has been moving like this. It is now somewhere here where its x position is 6.75 and its y position is 15.75. That is the meaning there. This is where the object at the end of that 3 seconds. Okay, I think we have done enough problems. Do you agree with me? I'm sure you must be an expert in solving problems like this now. Okay, that is the end of lesson 1, and I want you to learn the concept. Now, this lesson was actually full of concepts. I want you to learn them well and learn how to solve problems using those concepts. Well, I'll see you for lesson 2 later on.